Assalamualaikum and hi everyone, I'm Muhammad Nabil and I'll be presenting on how do we create a program delay. So let us go to the introduction first. So here I've write some points so that it will be easier for you guys to understand how the programs works. In PIC 4550 there are crystal oscillator called quartz or a RC circuit to generate the clock signal needed to control its operation. So this quartz is like it has its own natural frequency inside it. We can measure time by the number of oscillation of the clock. We use that to keep track of time. The third one, the instruction execution time is measured by using the instruction cycle clock, and one instruction cycle is equal to 4 times the crystal oscillator clock period. And let's go to the example. So this is one of the question of how do we create a delay program. So the question states that create a tutorial video on how to create a delay of 0.5 seconds with a crystal of 16 megahertz. So this is a little bit about the program. How do we understand it? So the question states that frequency is equivalent to 60 megahertz, which means in 1 second there is 16 mega oscillation. Period T is the time for one complete oscillation. So one complete oscillation is like this, where you have the should be like this from the beginning, from where we start, and it will be end at the same place. So this is what we call one period. So one oscillation takes 62.5 nanoseconds. How do I got this? I'm gonna show to you guys later. One instruction cycle takes 4 oscillations. This instruction cycle needs 62.5 nanoseconds multiplied by 4 so that we can get this value 250 nanoseconds. And then NOP takes up one instruction cycle. So what is NOP? NOP is an instruction that does nothing. It is perfect for creating time delays. Executing NOP takes one instruction cycle, which is we have calculated just now, 250 nanoseconds, and it needs to use macro to simplify the repetition of any instruction. And what is macro? So macro is a group of instructions that are grouped together and assigned a name. It is an input. An input to a macro is called argument. So one macro can have one or more arguments. Let us see how it's gonna be. This dup node is what we call as macro name. It stands for duplicate, NOP. And then this macro and this is what we call as macro keywords. This is my arguments. I'm just state this as my name, which is Nabil. And now this is how do we calculate from the question 0.5 seconds, and we need 16 megahertz. So this is how the calculation will be. First we take the 1 second and divide it by 16 megahertz, and we got this 62.5 nanosecond. And then we're gonna multiply it by 4 to get the period, and 62.5 nanoseconds multiplied by 4, it will be 250 nanosecond. And then we need to know how much the instruction that how much cycle do we need to create the delay program. And then here 0.5 second must be divided by the period, so that we know we need 2 million of cycles for create that delay program. And this is how my coding is. I'm just naming it as delay 0.5 second. This is the external loop. We're gonna use a loop so that it will be repeat again. This is my internal loop, which is duplicate node D247. Why I put 247 is because decrease loop count 1 has one instruction cycle, and then branch again has 2 instruction cycle, so that 1 plus 2 is 3, and we're gonna add with 247, and we got the 250. Here is internal, and then external, we're gonna times it by 250, and then again we're gonna times by 32, so that we got 2 million cycles. So this 250 will be execute 250 times, and then these two will be execute 32 times, so it will be producing a 2 million cycle. Now let's go to the MPLAB to do our coding. Here first I'm gonna go to configuration bits and uncheck this, and then oscillator must be in HS oscillator. Watch.timer will be disabled. Port BAD as digital, and single supply will be disabled. And then we go to file, new, and I've done the coding. Here's my coding. It is a simple program on how do we display my student ID. So my student ID is DE96550, and we got the off LED over here, and this is our macro duplicate node, macro Nabil, and here is my delay command. We got 247 plus with 3, and we're gonna times it by 250 and times it again with 32. This is my command. Gonna clear the electricity first, and then we're gonna display the number. So now I'm gonna go to save as. I'm gonna save it as program.asm. Then we're gonna go to project wizard, click on next. So the device will be PIC18 F4550, and then this next, and I'm gonna browse it. The file name will be just program without the ASM. We click on next. So let me find this program. and add it to the file and finish. So here I've done the coding, and we're gonna build all to see whether this coding is correct or not. And I've changed the name to delay.asm. So this is my coding. It's the same, where it will be displaying my student ID DE96550, and we got the macro over here and delay command over here. So first we go to view to the file register to see this to see how our delay works. So I'm going to choose a debugger to select tool and select MPLAB sim, and I'm gonna run first. So here this is if I'm keep on clicking on step into, the value of a 0x00 will be decreasing. So this is the internal. Once the 0x00 becomes 00, the 01 will be decreasing. So this 01 will be external. Wait, let us see. E, D, C, B, A, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so now we focus on 0x01 here. The 0x01 will be decreasing by 1. So if I'm keep on run it, it will be decreasing by that. So now we go to Proteus. This is a simple circuit. We have a 7-segment common cathode over here and some resistor, and of course we need PIC 18. And I'm gonna place the file. So here processor clock frequency will be 16, and here I'm gonna place the file of delay.hex, and I'm gonna run. And as you can see, DE96558. So this is what we call as delay 0.5 second. And that's all from me. Hopes that you can understand. I hope it can be very useful for you guys to do, and thank you very much.